Hey y'all, let's talk about agents and stuff. So one of the things that we observe supporting customers is most people are building agents wrong. Normally, what ends up happening is a very well-meaning CEO shows up on the head of AI's desk and says, "Go make us AI native." And that means a lot of things to a lot of different people, but normally what happens is this, head of AI, center of excellence, head of data platform, choose what you call this department, goes around and they have a webinar with each and every business unit, and they try and explain what AI is, what an LLM is, what an agent is, what prompt is. And then they ask the sales ops team, the salesperson, the marketing person, the support engineer, whomever it is, and say, "Hey, tell me what you do here." And there's a lot of nuance to all of our jobs. And so that, sales ops person, "Oh, I'm responsible for making sure that sales team's on track. I help make sure that sales opportunities are properly constructed, yada, yada, yada." And then that data scientist goes back and says, "Okay, I'm going to build you an agent." And they try to recreate what they've understood from that subject matter expert in prompt data and typically, a model or several models. And they come back and surprise, it's not that good. And they say, "Oh, you missed the nuance. When I said budget, I really just meant resources allocated," or so on and so forth. And this doesn't work because we're playing telephone. Rather than having the person that is most familiar with the problem that we're asking the agent to solve, rather than having the person who knows the most but tell the agent directly, we're passing the information through several layers of abstraction, and often they're very lossy abstractions. And there's a simple fix, right? It's a short, simple webinar, 4 easy slides. We just need to invert who's instructing the agent. And obviously I'm doing a lot of hand waving over like a really difficult problem, but our job as AI makers, as AI platform people, is how do I support this workflow? How do I make it such that the folks that know the job the best are able to directly be evaluating, instructing, coaching, cajoling the agent to complete whatever task it is that you're asking them to do, whether it is synchronous task of go and process this information and give me a report right now, or on a schedule of, "Hey, every Monday morning I want you to do XYZ." And so I'm going to show you how we do it in Hypermode. Your mileage may vary. You may take a different approach if you've built this yourself. But our general tactic is we call it hire, iterate, harden, where the goal is that you essentially, in a no-code way, have a subject matter expert hire the agent. Say, "Hey, this is what your job is going to be. These are the tasks I expect you to do." Iterate, continue to interact with them over again, primarily a chat-based interface, and say, "Oh, hey, that's not quite right. That's not quite right. That's not quite right." And then when it finally is sufficiently close, you can extract that as code and then pass it over to be owned and managed by the AI platform team, the data platform team. And kind of the relationship we expect for between the AI platform team and the subject matter expert is the AI platform team is responsible for tools, MCP servers, authentication, privileged access. An agent created by a salesperson should be able to do XYZ. And then the subject matter expert is the one who says, "And this is the jobs to be done." So without too much further ado, let me show you Hypermode. Uh, Will, any questions so far in the chat? I know I'm kind of moving fast.
Not that I see yet, but folks,
Cool.
feel free to share in the chat. Maybe Kevin, could you zoom in a little bit
Absolutely.
before we dive into the demo here?
Awesome. So the kind of one of the fundamental like beliefs behind Hypermode is most people don't talk like an LLM, or maybe we do, but we don't speak agent so good. And so being able to generate a system prompt or designing an agent can be difficult. And so basically what we've constructed is a concierge to help you build your agent. And so what I'm going to show you today is what I'll call the like ready to go set or ready to go state of Hypermode, where the assumption here is, you have, set up your tools, you set up your connections, and I've handed over this tool to let's pretend today that we've handed this tool over to our marketing team, and we say, I'd like to build a product And what you'll notice here is I'm going to be giving really terse instruction to the system. I think sometimes you see really large system prompts or really large prompts where it's 4 pages and 7 paragraphs of if this, do that. Here's the specific formatting I like. Most people don't interact that way. And the expectation here is like in the same way you'd be talking to someone over Slack. That's the way you should be able to construct your agent. Let's say, I'd like represent hypermode.com. And what's going to happen is Hypermode's going to ask me a series of questions. Once it feels sufficiently certain that it knows what I'm trying to build, it'll go ahead and give me like a version 1 or a draft of that agent. What's happening in the background is we're constructing what's called a Modus app. Modus is an open source framework that we've made that essentially uses, excuse me, an open source framework that allows you essentially, like as a runtime, manage large fleets of agents. And so what's being built under the covers here is a Modus application, such that then if you ever want to extract this as code, it's the exact same application you've been working against. We're just going to clone it into your Git repo. And so here, what's happened is Hypermode's responded and say, hey, we're going to build a Hypermode. Hypermode is an AI development platform. Hypermode's mostly publishing, sharing, remixing agents, exporting this open source code, and then saying, okay, let's give me a little bit more info on the agent's details. And so I might say, Sally, and let's say make sure she's concise. We'll use Hypermode's blog as context to make sure that this Sally follows our writing style. And so, again, still synthesizing questions. I'll say, let's do developers. If I could spell, that'd be really helpful. And there we go. So what's happened is Hypermode's called a tool called create agent. And essentially it's generated essentially a manifest and is generated essentially Sally. We can go in and click on the info panel here. Over here on the left, basically, if you are familiar, these are all MCP servers. We've got 2,000 MCP servers that we give you access to. You can bring your own if, let's say, you have like internal tools that you've curated or want to provide specialized access to. But in this case, I'm going to go ahead and connect to GitHub, and then Ref, which is a great platform that does developer documentation. And so what's happened here is I've OAuthed into my GitHub account, and so Sally is going to be able to take actions on my behalf in GitHub. Ref is, there's no authentication there, but we'll be able to access directly. Over here in the About panel, there's no expectation that you would actually have to touch this, but let's say you are, you're an AI, expert. You can go in here and actually update the system prompt and provide specific context or behaviors if you're not quite getting what you want. And also, for example, if you have preferences on model, if let's say, oh, hey, I'm doing a bunch of deep reasoning, I want to use O3, Hypermode will default select a model for you. But if you have strong preferences, you can go ahead and override that. Cool. So let's go back and go ahead and interact with Sally. I'll kick off a new thread with her, and I'll say, mic check. What tools do you have access to? And so now what's going to happen is Sally's going to share with me, hey, those MCP connections that you just connected, these work. So yep, I've got access to GitHub. I have access to a couple of built-in tools that all Hypermode agents have. And then technical documentation search, that's Ref. Say that's great. Let's Hypermode's tagline from its website. And so we're going to go ahead and ask Hypermode or Sally to go out and say, hey, we're doing a little bit of product marketing, we're releasing some products. I'm going to train her how to essentially read a blog post and then go ahead and make some recommendations of new taglines to our website. And because I've given her access to GitHub, we'll go ahead and see if she's able to like submit a pull request and make that change for us. While Sally's thinking, I'm going to go pick a blog post for us to. I'll use the Modus V1 age runtime. Will's going to be talking about that. I'll ask her to come up with taglines associated with this. And associated with this blog. And so again, like this is very simple LLM work that we're doing. And so we've got a couple of taglines and then say, great, can you find hypermode.com's tagline in our GitHub? And the way I tend to operate is I tend to think of this like it's a very smart intern. I really doubt Sally's going to be able to immediately know what repo to even look in. Oh, see, here we go. I wasn't able to, that's interesting. Tool call failed. And so what's happening is my GitHub MCP server isn't quite working. Let's try and authenticate again. I haven't had that happen in a long time. Let's kick off a new thread and try. It's always the danger of live demos. So we're going to try again. And with all agentic systems, a lot of this is going to be in, oh, interesting. I'll flip through a couple more pieces. Will, I'll hand over the mic to you a little bit earlier to go through the knowledge graph components, and then hopefully I can jump back on after I've debugged what I broke in my Hypermode account. I'll flip over to maybe a successful run that I was doing a little bit earlier. So this is Hagrid. So what I've trained Hagrid to do is essentially check the weather, and then we have a fake website for Van Gundy Farms. It's the best farm at my house that doesn't exist. And basically, I've trained Hagrid to go out and look at a weather report and then basically tell me whether or not I should leave the farm open or closed. We have a fake farmer's market that we run here. And basically, what I ended up doing was handing it a weather report, having it go and do some research on our current farming plans in linear, and then making a decision of like, hey, you know what? It's storming. We're not going to do that. And the advantage here is I can actually have this run on a daily, weekly, hourly basis. And so what I can do is essentially I can create a task. What that is doing is really synthesizing the conversation that I've had with Hagrid over the last 30 minutes, taking that into essentially a one-shot prompt, where rather than expecting you to be able to come up with all of these steps, we say, hey, interact as you normally would, but Hypermode can go ahead and generate the task. I say, great, weather closure automation. I can save that task. And then what I can end up doing is the next time I talk to Hagrid, kick off a new thread, I've got this new task that shows up here that I can automate. And I can set this to go on a webhook, on a trigger, on a schedule, in reaction to another agent's actions. And so I can schedule that out. But let's say, I really want to scale Hagrid. What I can end up doing is exporting Hagrid to code or Grapevine to code. And what's going to happen is we're going to export not only essentially like the model connections, the tool connections, all those other pieces, but also all like the memories and learnings that Hagrid has had or Grapevine has had from working with me. Where maybe it's defined, hey, you know what, when Kevin says go to linear, it's actually this specific workspace that he's talking to, and we're able to construct this knowledge graph that then supports Grapevine's work with me. And will dive into much more about that. But here on the develop side, I now see Grapevine has been essentially surfaced as an API. This is essentially a serverless function that I can hit and integrate into my application. But I want to actually like inspect that code. This is the essentially the Modus application that runs Haggard, the agentic service. And if I go into, for example, the Modus.json file, it's maybe a little bit hard to read, but it says, hey, we're using GPT-4.1, we're using Hypermode's model router service. If I go into the actual agent.go code, I can actually, again, treat this like any other agent that I've written in code, where I can actually come in here and say, okay, here's the system prompt. I can adjust the temperature and creativity. And again, you're going to expect to custody and manage this just like any other chunk of software. Very cool. Will, I'm going to go ahead and try and debug what I broke with my GitHub authentication because it clearly just worked now. Would you mind taking over a little early?
Absolutely. We had a really good question from Sumit that I just want to touch on. And he was asking, how do we guide the process to reach convergence over multiple iterations, like a feedback loop? And I think when Kevin showed that task feature, right? Like we think of that as, you're interacting with your agents because we're working with LLMs. This can be non-deterministic, right? But we think of this as the more you interact with your agent, the smarter it gets. It's going to be able to learn from those interactions and persist those things in agent memory and understand your preferences, these sorts of things. And what Kevin showed with creating that task was basically when I've had some successful run and an agent has done something. Kevin was showing how we could uh, create a product marketing agent to understand a blog post and updates and copy on a website. We can save that as a task so that we're able to kick that off via API or maybe an email trigger or something like that, so that we have something more well prescribed, this agent interaction as a task rather than sort of kicking off a new agent interaction, a new thread each time. So Samit, hopefully that gets at your question of pointing out like, hey, how do we sort of impose some determinism or some like well functioning workflow on top of our agents? And that's really what tasks in Hypermode agents is really designed for.
Yeah, and I'll add a little bit extra color. One of the things that we also see folks doing is like you can default your task to run as what we'll call human in the loop. And so, kind of, for example, as you shared, like when you maybe start that task and you just train the intern how to do a thing, that cone of fire might be pretty wide. And you can say, hey, rather than merging your pull request yourself, right? You can say, hey, either like submit the PR and shoot me a Slack message, or we have a feature in Hypermode called Inbox, where I'll say, hey, just inbox me and I want to review your work. And what you may observe is, oh, you know what, it's not quite doing what I want. And that's why, to kind of Will's point, you'll go back and provide additional instructions and additional instructions. And then you'll be updating that task, essentially like set of instructions, to then be more and more crisp, to be like, when I said do this, I really meant do exactly this. And that's how you can really start to narrow the expected outcomes from your agent.
We have another great question here asking about working with multiple agents. So, like what we've been showing so far are very domain specific agents. And I think this is an important takeaway for successfully building agents is that you want to give them, as Kevin said, sort of like intern type job description. So they're good at product marketing. They're good at understanding, interpreting the weather for farm operations. They're good at maybe reviewing code, these sorts of things. But the question is really, are we able to talk to multiple agents at the same time? Thinking like, are we able to kind of like string together a workflow across multiple agents? I'll take a first stab at that maybe, and then Kevin, if you want to add anything.
Sure.
Cool. So one thing that I'll get into in a minute that I think is really interesting is with Modus and the way that we've built this agent abstraction in Modus is all based on message passing and the actor framework. And so built into these abstractions in Modus is this concept of message passing. And so there is a way in this abstraction that you can send a message to an agent, and that can be like a chat or something like that. But an agent can also send a message to another agent in this Modus app. And we'll see an example of this when we start looking at the code in a minute. So that's one way to implement this. There are also some interesting things evolving with like Google's agent to agent protocol that sort of allow you to publish like a agent card that describes like the type of tasks and um, functions that an agent is able to complete, and string these together in a workflow. So those are some things to think about. Do you want to add anything to that, Kevin?
Yeah, I'll give like maybe like the what I call like the threads or like UI specific element as well. One of the features that we rolled out really early that we decided to pull back and are going to work on again um, is basically if you notice like our chat system looks a lot like an iMessage thread. And one of the things that we're going to make available to folks is the ability to essentially have like a group chat with agents. There are about like idiosyncrasies there. But the way we tend to expect to use it is for like A/B testing of instructions of, hey, I want to use a different model and see is 4.1 mini as useful as 4.0 for whatever task I'm trying to complete. And you then be able to essentially like parallel chat with multiple agents. I don't think that's quite what you're getting at with your question, but those are ways in which we're starting to look at allowing like I don't know, like load balancing, but to like distributing work across like several agents to like do the A/B testing component. But then the next chunk of that is essentially in the task elements you saw of like being able to expose those agents essentially as quote unquote tools is what A to A supports. Those tools to other agents that you can then be like having in like work be flowing through like several pipelines of effort. And then Michael also had another question here of how will agents become smarter? What's the internet agent that goes back to for context? That is a great softball question. Will, would you like to give the second half of this presentation talk about how we're going to make our agents smarter using knowledge graphs?
Absolutely, yeah. Let's dive into that. That's a great question from Michael. So what Kevin showed was building these domain-specific agents that can connect via MCP to expose tools to interact with GitHub, to search the web, this sort of functionality. And what I want to do now is maybe dive under the hood a little bit and talk about some of the open source technology and concepts that make this Hypermode agents experience possible. So one thing we want to look at is how can we make this agent smarter? And the short answer to that is with context. But let's take a step back to understand really what we mean when we're talking about context with agents specifically. So Anthropic published this blog post, Building Effective Agents, several months ago, and talked about this concept of the augmented LLM. So the basic interaction with an LLM is we give it some input, a prompt, we get some generated text as a response out to that. And in order to have agents that actually are able to understand and interact with their environment, we need to add retrieval tools and memory to our model. This is, I think, really the basis of what defines an agent. Like what makes an agent is that the model is able to, through tool calling, influence the control flow in how it responds to the prompt and the query. And these three pieces, retrieval, tools, and memory, are examples of what we mean when we talk about context for agents. So if we were to define context, I think it would be something like, the relevant background information, state, and the relational knowledge that enables our agent to interpret inputs accurately, make better decisions, and generate the correct responses for a given situation. So this enables our agent to have things like situational understanding, sustained coherence, where we're able to maintain a long-running interaction with our agents. Our agent is able to understand as we move through the conversation and the tasks what we're referring to. the agent's able to learn from these interactions. And I think this is a big important piece of what enables that tasks feature that Kevin was showing. And of course, also have access to dynamic real world information as that is evolving. And so this can include sort of the immediate context. So this would be like our conversation history with the agent. This could be, user preference or specific parameters that we're giving the agent in a chat message instruction. This can also be knowledge that we persist, like facts, patterns that we've learned, maybe like historical interactions that we're sort of curating those preferences over time. Structural relationships, which could be connections between entities and concepts. They're semantic relationships, right? So this is an important area that knowledge graphs play here. And then environmental awareness, so understanding what tools are available to the agent, system state, and any constraints that we might have over some of those connections. Now, you've probably heard of this concept of RAG, or retrieval augmented generation. And we also have this concept of agent memory. And I think really when we compare these two, it's maybe not always exactly black and white. Maybe there's a bit of a spectrum here. But typically with RAG, we're thinking of accessing some source of truth, some like large knowledge corpus that might be shared across the entire enterprise. This can be mostly typically static information. Updates are done in batches. This is typically unstructured data. But then if we think about memory on the other end of the spectrum, well, memory comes from agent interactions. So this is sort of a constant stream of information that grows over time. And this is typically based on like a single user interaction, or maybe like a group of user in a workspace with a single agent. And the timeline component is important here, right? There's some sort of like decay function as older sort of message history becomes less useful in context. And this can be both structured and unstructured data. And we've seen a few times where we mentioned, and we're talking about context and what we mean by that as knowledge. And we're talking about entities and those relationships. So this is where knowledge graphs come in. A knowledge graph, I think a simple definition, and maybe this is like a little technical definition, but a simple way to think about a knowledge graph is an instance of a property graph. And a property graph is really just a data model that we use to represent things, the entities. These are the nodes in our graph. Nodes can have one or more labels that describe what the type of the thing is. So a way to group nodes or entities. You can think of this as kind of like a table from the relational data world. And then we have relationships that connect these nodes, and every relationship has a single type and direction. And this is where the semantics come into play. That the data model is representing not just that there's some relationship between two nodes, but really that there is a semantic relationship. We know the type of relationship. So in this example, this comes from a conference that I gave a talk at a few months ago. So we have person Will. I'm giving a talk. The talk has a topic, and the semantics of that, how those entities are related, is embedded in the data model. And the actual attributes, these are the properties of the property graph model, are stored as arbitrary key value pair properties. So name, Will, company name, Hypermode, employed by, current, true, this sort of thing. I think the most important concept in a knowledge graph, think of especially as you're implementing the knowledge graph, is that there's some canonical representation for the thing, whether that's a topic, a person, a company, whatever it is, but there's one single canonical representation of that, so that when you see that thing again, so example, here we have this node person named Will. He's employed by a company, he's presenting a talk. Like when I see Will doing something else again, I don't create a new Will node, I just create a new relationship to that existing Will node. And that concept allows me to traverse the graph to find important connected information. So that's the basic structure that we're talking about when we say knowledge graph. It's really like a structure. How do we actually like work with knowledge graphs? We typically do this using a graph database. Graph databases allow us to model, store, and query data as a graph. Hypermode builds and maintains an open source graph database called dgraph. Dgraph is really designed for horizontal scalability, so large data in terms of volume, and uses the property graph model and a query language called DQL to query and work with graph data. So if we have our graph data that we're building in dgraph, how do we expose this knowledge graph to our agents? Well, on the left here is a screenshot of DQL. So if we're writing a typical application, we might have like parameterized DQL queries. Here we're looking at a knowledge graph of news, and we're searching for news items that mention certain locations within, what is this, 50 kilometers of New York City. And then we're traversing the graph to find the articles and the topics about news in that area. So we might sort of have a parameter for the latitude and longitude of a certain area that we're looking for news for, and that's our entry point to the graph, and then we traverse from there. And on the right, we're showing the data model for this news graph. And one thing I want to point out about graph queries is that we typically use some like index as a starting point for traversing the graph, and that could be maybe we know the name of the entity we want to search for, and we want to find all of its connections and these sorts of things. Maybe the geospatial index is our entry point, but we can also have sort of an unstructured data entry point into our graph. This is this concept of a lexical graph. If you've heard of the concept of graph rag, this is typically using vectors and embeddings. So we might take the text of an article, chunk that up, generate embeddings of each chunk or paragraph of the article, model those as chunk nodes with some embedding property stored on that node. And then when we're doing a graph rag or a rag traversal, that vector search is just the entry point to traversing the graph. Then we'll see, okay, what is the article that chunk is connected to? What are the topics? What are other articles that share the same topic? And we can traverse the graph that way. So sort of by using that query language, that's one way we can interface with our knowledge graph. But another way is to expose tools through MCP. So Kevin talked briefly about MCP, Model Context Protocol, as kind of a way to enable connections for agents. So we were looking at like the GitHub MCP server, these sorts of things. MCP is kind of compared to like the USB-C, kind of like one standard protocol for remote services, which is, I think, maybe a good way to conceptually understand that, like, fundamentally MCP is just a protocol, right? It's some standard. And so here in the threads experience, we saw that each one of these connections that we're enabling are just MCP servers. MCP servers are really useful because they're the thing that you kind of only have to build once, and then can be used by multiple applications for different use cases. So if we have the dgraph MCP server, which is enabling access to knowledge graph for AI agents, that can be used by Hypermode agents, but it can also be used by developer tools like Windsurf, Cursor, Claude Desktop, these sorts of things. So we can use these MCP servers to expose our developer tool or expose our API if we're sort of a SaaS service. And we only need to build these once, which is Very beneficial for sort of AI app users and also for developer tools and API developers. I borrowed this slide from the deeplearning.ai short course on MCP. This was a really good short course that not only introduces the concepts and how to, excuse me, how to use MCP, but also how to build your own MCP servers. And this slide is kind of pointing out that MCP servers expose tools. So we saw this concept of like the augmented LLM. So tools that enables an agent to interact and understand its environment, but then also things like resources that can be read-only static data or prompt templates that allow us to get started. So we may have defined a prompt that we know that works well with, say, like the dgraph MCP for maybe creating or a fictitious graph data, this sort of thing. So dgraph exposes an MCP endpoint from each cluster that exposes tools for understanding the schema of the graph, running queries, mutations, updating the graph as well. We'll see how to use dgraph with an agent in Modus in a minute, but I wrote a blog post earlier this week that talked about how to use the dgraph MCP server in the context of like understanding new developer tools with tools like Claude Desktop, Windsurf, and these sorts of things. So if you're interested in that, here's a good resource. So what I want to do next is dive into Modus, which is our agent framework that Kevin talked a little bit about, because one thing that I think is interesting here, we've talked about sort of dgraph, this knowledge graph layer, but I want to see how under the hood we're actually able to orchestrate these agent interactions. But maybe I'll pause here for a minute before we jump into this and see if there's any questions or comments in the chat that we should take a look at.
I've been trying to answer them as they come through in chat. There's one question earlier about essentially being able to interact with like essentially like an orchestrator agent that maybe is like coordinating work across several other agents that are maybe other threads agents or Modus applications. And can I share like, hey, like this is a thing that we're working on. The right UI for that we found is pretty tricky. And so right now we're the current working method is like swimming alongside tools. But if folks have ideas or preferences or have seen that done well, let us know. And then there's another question about are you able to use Neo4j as your knowledge graph? Wenling is not yet familiar with dgraph. Short answer is yes. We have a Neo4j connector. Funnily enough, Will and I are actually both Neo4j alumni. Will, anything you want to share on the Neo4j connector?
Yeah, I think like an important thing to point out here is that I talked about dgraph and the concept of like the property graph model and starting with like a vector search to as my entry point for traversing the graph, and like these concepts all apply if you're using dgraph, Neo4j. Kuzu has similar functionality. I think we like to show and demonstrate dgraph because that's a piece of technology that we maintain. But I think it's really important, and especially like showing the this architecture diagram here. Like we want to have the pieces that enable you to build agentic applications and put agents in production. But really, like by building all of this on top of open source technology, it's incrementally adoptable and plug and play based on different tools that you're using. So if you're using Neo4j, that's great. We have like first party support for that in Modus. But yeah, I think understanding like the fundamental concepts is kind of really important. You can kind of plug and play the individual tooling as necessary.
Yeah, and one thing I'll emphasize here is like Hypermode is fundamentally like an open platform where no matter what your favorite tool is, we want to make sure we integrate with it. Where, for example, if you say, hey, I really want to use Mem0 as my agent memory, I don't want to use a knowledge graph, like it's perfectly okay. Or you want to use a different vector database or whatever it may be. the thing that we think is most critical for succeeding with building out agentic services is like how quickly can you iterate on that service? And that's, I mean, if you look at even just like the threads and agent building experience, our goal is really like how can you as quickly as humanly possible understand the contours of the way that system needs to come together so you can figure out what's actually important. Like don't worry about finding the best vector database there is if it turns out vector search is an important part of your, the agent that you're building or the problem that you're solving. And so that's kind of the philosophy behind us saying, hey, we have one of everything for you. It's not to say that we think we can build, the 10 out of 10 thing across the entire stack. I think we can over a long period of time, but that's not the point. The point is like we want to enable rapid iteration. And so yeah, you can always bring your favorite tool to Hypermode.
Cool. Well, let's take a look at this Modus AI agent orchestration framework under the hood a little bit. So we've said several times now that Modus is the AI agent framework piece that's orchestrating our interaction with models, data, tool calling, and we saw that in the threads experience. Fundamentally, the idea with Modus is we write a function, and that leverages the Modus SDK, which has abstractions for working with data, working with models, and creating agents. Modus uses GraphQL to take the logic in your functions, inspect the signature of those functions and the types that you've defined, and generate a unified GraphQL API that exposes the functionality you've defined in your functions. Modus uses WebAssembly under the hood. You don't need to understand or learn anything related to WebAssembly to leverage it, but this is the core of the Modus runtime. We think this is really important for scalability. WebAssembly gives us some interesting things with sandboxing and being able to have a individual execution space for each agent. So there's a blog post is actually the blog post that Kevin's product marketing agent was using, talking about our vision for V.1 of Modus, talking about what I just mentioned, the need for runtime and SDK rather than just a library for enabling agents at scale. Also goes into detail, and we'll take a look at this in a minute, that each agent in Modus is an actor, leveraging the actor framework. If you're familiar with this gives each agent its own execution context, mailbox to send and receive messages, and a life cycle. We saw this concept of tasks earlier, where we're able to sort of train our agent over time and schedule these learned skills. And then we've talked a few times about the importance of being able to leverage tools from MCP, but we can also create custom tools as Modus functions. Cool. So let's take a look at a demo of how we can create an agent that is able to use knowledge graph-based memory with Modus and dgraph. The code for this is in the Modus recipes GitHub repo, which you can find lots of different examples for working with different things using Modus. But let's take a look here at the code. So the first thing we're going to look at is the Modus JSON file. And this is our app manifest. And so here we're defining the endpoint we want to expose, which is going to be a GraphQL endpoint, any models that we're going to use. We're using a feature of Hypermode called the model router. So this allows us to, using a single API token, access either open source models that are hosted on Hypermode, or also access OpenAI, Anthropic models, these sorts of things. And we also have a connection to a dgraph instance. If we look at the main.go code here, so I should say this app is written in Go, which is one of the more common languages we see using Modus. We can also write in a TypeScript-like language called assembly script. And here we have a few functions for creating a conversation, continuing a chat, chat history, and deleting an agent. If we take a look at the chat agent, so you can see here, like we're creating an agent that is going to use models and interact with dgraph and respond to chat messages. But some important concepts from the uh, Modus agent is that the agent has state, in this case, just a chat history, which is a string. And so we just need to define functions for how we can get state, set state. And then we also set an important abstraction of Modus agents is this idea of sending messages. So our agent is going to be able to respond to new user message. So we're going to take in a new message and call the LLM and respond to that message or get the chat history. Here's the logic for chat. We're basically calling the LLM with tools. And if we look at the system prompt for the specific agent, we're saying, when you get a question, do some entity extraction. We're defining the tools that the agent is going to use. So these map to Modus functions. And essentially what we're doing is entity extraction, understanding the date that something happened, and generating a list of entities that are then going to be persisted in our graph. So let's go ahead and run this. We'll say Modus dev. This is going to compile our Modus app and take the functions that we've defined and expose a GraphQL API for these. So we can go to, this is the Modus API Explorer, which shows the GraphQL endpoint that is generated from these functions. We also have a little front-end interface here that we're going to use to interact with our agent. So let's say Will works at Hypermode in developer experience. Kevin works at Hypermode and is the CEO. Will and Kevin are presenting a webinar at ODSC today, and Will and Kevin worked together at Neo4j previously. Now, when I send this message, our Modus app is going to extract these entities and construct a knowledge graph and persist that in dgraph. This is the dgraph instance that I have running. And here's a dgraph query that we're going to use, which is basically show me all of the facts and the entities connected to these facts. If we run this query now, we can see that there's no data in the graph. If we switch over to Hypermode, I'll show where this is running. So here's Hypermode. This is the Hypermode console. I'm borrowing this Discord live stream graph. Cool. And we can see no data came back from this. So let's switch back to our chat and we'll go ahead and send our agent this message. So our agent is going to parse out the entities and persist that in the graph. So here's some facts that it's found. And we can say, like, I don't know, what is Will doing today? And we can see Will's presenting a webinar at ODC with Kevin. And so the agent is leveraging this data, searching for Will in the knowledge graph and providing that as context to respond to these messages. So we can say something like, how do Will and Kevin know each other. Well, they know each other from working together previously at Neo4j. And now if we go back to the graph, let's run this query again. So this is just looking for all facts in the graph, like when they happened, what are the entities? And we can see here that we have some entities that were extracted. So the blue, these are the facts, these are the statements that were made, right? So Will and Kevin work together at Neo4j. What are the entities? Well, the entity is Neo4j, entity is Will, and entity is Kevin. And so we can traverse the graph to find more information about this, right? So Will works at this entity Hypermode. Will and Kevin are both connected to ODSC. So we can see how we're able to build up this knowledge graph and traverse the graph to find the relevant context to answer our questions as they come up. Cool. So that was a quick look at using Modus and dgraph together with this agent abstraction for working with AI agents in Modus. And this is a look at kind of what is underpinning that Hypermode agents threads experience that Kevin was showing earlier. Hypermode agents is currently in early access. So there's a QR code there, the link hype.foo/agents. Maybe you can drop that in the chat for folks to sign up for the early access and get started creating your own sort of domain expert agents. Cool. Well, that's all that I wanted to share.
Yeah, and we've got a couple of minutes for questions, and I will very briefly share my screen. Turns out it was Okta, so my bad. But here's the agent we ended up building. Basically, I generated that new tagline with our product marker. I recreated it to reset the connection. Drafted a pull request for us using the GitHub tool. Went through, found our tagline, submitted a PR to change it, and then if you check the Eversell preview deployment, visit preview, it updated our homepage tagline. So as always, an upstream provider has kicked my butt. But anyway, questions. So there are a few folks where one, does the Modus framework support multi-agent architecture now? How does it compare to LangGraph? What are its flexibilities and what are its largest advantages? Will, lead the way.
Yeah, so I think the multi-agent architecture. So yeah, so when I was showing the chat agent, and we had within the Modus app, we were creating the agent. The agent had some life cycle and some state. We were sending messages to the agent. I'd say the abstraction for working with multiple agents in one Modus app is this idea of message passing. So we saw we were sending a message to an agent from outside the Modus function, right? So we'd write a Modus function that was like new chat message, and in that chat message function in Modus, we're sending a message to the agent. But in the Modus app, we can have multiple agents that have different system prompts, access to different tools, and different state and different messages that they're able to send and respond to. And we can have an agent post a message to another agent to sort of piece together these sort of workflows. So that's the basic abstraction that would enable that sort of multi-agent architecture. And the other piece of this question, which is how would you compare this to LangGraph? I would say, one, we talked about this idea of library versus runtime and SDK, right? So in LangGraph, we have a library for constructing, these sort of, I think LangGraph has different abstractions for things like workflows, right? Where we're sort of destructing like a directed acyclic graph of workflows, which is where the graph piece comes in LangGraph. But with Modus, I think we're aiming much more for a vision where we have many agents with state deployed working together. And to enable that vision, I think we really need tight control over the runtime to have really strict control over the execution layer, this sort of thing. So I'd say that's maybe the biggest difference with maybe Modus and LangGraph is the abstraction that they expose, right? So the agents in Modus are using the actor framework, which gives us the ability to send messages and also leverages like a runtime rather than sort of just a library and SDK.
Yeah, and I'll give a concrete example, and then I'll talk a little bit about being WebAssembly based. Like, one example there is like, for example, connection pooling is not going to be handled by like a library for you. So if let's say you have 1,000 concurrent chats going on with 1,000 instances or 100,000 instances of your chat agent doing something, you're going to have to handle the connection pooling of like the RAG or the knowledge graph calls that it's making. You're going to have to handle that in your application yourself. But for example, if you're deploying that same service in Modus, we would handle that actual connection pooling so that you don't accidentally DDoS your database. It's just like stuff like that where, depending on the altitude that you're operating against, I think LangChain and LangGraph have like a bunch of really phenomenal abstractions, but there's just trade-offs based on like where you sit in the stack. And then the latter part is, the other component is like, because Modus is based in WebAssembly or is WebAssembly compatible, it does a really good job of essentially having these like atomic runs. And so you imagine I'm pulling up an agent to briefly do a little bit of work for me, and then I want it to be able to shut down and evaporate. That containerization works really, really, really well, especially at I have 10,000 agents doing 100,000 jobs. It works really well at that sort of scale. Nathan had a question like, hey, what are two business cases of customers using GraphMirror for features of Modus for? I think one of my favorites that we see a lot is versions of entity resolution. Graphs are so good at this, and it's really important when you have these disambiguation problems with agents. The canonical example I always share is the Jaguar runs down the road. Depending on your context, maybe we're talking about a cat in the jungle, or maybe we're talking about a car on a street. And graphs do a really good job of being able to figure out if the object that you're talking about with some level of certainty is the same object that maybe another thing is referencing. So you're like, is Bob Smith, Robert William Smith, are these the same person? And then when your agent is then trying to figure out what does Bob want to have for lunch, the branched context is super valuable. Like, oh, well, we know Robert Smith always gets a ham and cheese sandwich. We can make some guesses if we think that is the same, entity, human, whatever it may be. So that's a big one, especially for audience generation, especially when you are merging like your own data with like third-party or open source data to do audience generation, recommendation systems, intelligent, spooky stuff, catching bad guys, all that sort of stuff. Another great use case we see a lot of is, again, we'll talk about this a little bit, of essentially taking like large corpuses of data and then synthesizing them into something else. We see this where there is a large pharmaceutical company that automates study generation, where if you're taking a drug and you want to do human trials, there's a bunch of work you need to do to design that that human trial. There's many phases to it. And basically what you can do is you can take that information, munge it into a graph, and then that essentially gives your agents really nice handles to then generate a well-designed, thoughtfully created study to make sure humans can, with as little risk as possible, figure out if this drug is going to solve that ailment. Does the graph become bigger and messier as time goes on without cleaning? Well, tell me about index-free adjacency.
Yeah, so when we're talking about graph databases, one thing that graph databases are really, really good at is traversing the graph, and doing this in constant time that is not dependent on the overall size of the graph. So this means that once I find my starting point into the graph, so my example of using like the geospatial index or maybe like a vector search as my starting point, then I'm able to traverse the graph in constant time, no matter how big the graph is. And this is a really, really important feature of graph databases. As Kevin said, it's called index-free adjacency. It means that I'm not using like an index lookup that slows down over time as my data grows. Instead, I'm basically just like chasing pointers to something that graphs and computers are really good at. So in terms of like dealing with scale and in terms of like size of the graph, like this is an optimization built in to graph databases. But related to this and your other question of like housekeeping processes for cleaning the graph as memory, concerns of like messy or quality of data, like for sure, I think especially in the context of memory, like where this like stream of data is just growing over time, like with more and more interactions with my agents, we need to think of one of this like time decay that more recent interactions are probably going to be weighted higher. And we also maybe want to think of this, introducing this idea of like summarization into the memory graph, where we're able to take a large like subgraph, summarize that, and we're only traversing to the summary node, not through the specific subgraph. So these are some techniques that we can introduce to, especially for memory, to deal with like the complexity of the graph as that's growing over time. But I will say also being able to have an opinionated data model. You'll hear the word ontology thrown around a lot, and I think really for AI agents specifically, and finding relevant context from graphs, I think that the piece of an ontology that can be interesting is the data model, like essentially like the graph schema. So if you have some well reasoned and thought about and understood graph schema that you're imposing on your knowledge graph, that can really help your graph to scale and can really address some of that like messy data quality issues as well.
Very cool. I think we declare victory. Thank you all so much for coming. It's fun getting to show off stuff, and thanks for your patience as I had the demo gods give me a hard time, but we got through it, and proof that we're actually building agents and we're not just showing recordings.
Cool. Yeah. And thanks everyone for the great questions and
Yeah.
chat.